be recording this webinar, and we'll post the recording on the wiki page along with the presentations. So, for the introduction, I'm Stephen Vale. I'm the Regional Advisor in Statistics at UNECE, the United Nations Economic Commission for Europe in Geneva. And I'd like to welcome everybody to this first webinar in a series that we have planned to be organized jointly between Global Forum for Geography and Statistics, GFGS, the European Free Trade Association, EFTA, and UNECE. These webinars will consider different aspects of using geospatial and statistical information together. And we aim to bring you approximately one every month to 6 weeks on various topics. The format that we've decided to follow is to have about an hour for the webinar, and that will comprise 2 presentations, about 15 minutes each, followed by an open discussion. I would very much encourage you, because we are so many on this call, to write any questions that you might have for the presenters in the chat function in WebEx. Then I can take the questions from the chat, put them on the screen, and ask the presenters to respond to them. I would also like to ask you all to please keep your microphones on mute. We should easily be over 100 participants when everybody has joined, so you can understand the possibility for a lot of background noise will be quite high. I would also advise that everybody except the speakers, please keep your camera off. That will improve the quality of the audio for everybody. So that's the introduction from my side. I'd like to ask our 2 partners, first of all GFGS, in the form of the head of the group, Vilni, to just say a few words, and then after Vilni we'll have Volker from EFTA.
Thanks a lot, Stephen, and thank you for the very good cooperation so far. And thank you to Statistics Portugal for providing this splendid symbol or brand for GFGS. Next. I'll just say a few words about the GFGS. It started as a voluntary cross-disciplinary forum in 2014 and as a task force connected to EFGS, the European Forum for Geography and Statistics, and has since developed, and now we are about 15 different institutions and more than 20 people involved. Here you will also find the link in the lower part of this slide and find more information. Next. When the pandemic started, we found out that the usual physical meetings and possibilities were limited, so we started a seminar in late May with a focus on COVID-19, and you will find the presentations also in the Stat Week of UNECE in the link below, and here you have the moderator and presenters here. Next. And here we are today. We have had some discussions in the GFGS about how to develop a series of what we call global coffee talks. And I give the word back to you, Stephen. Thank you very much.
Great, thanks, Vilni. So I now give the floor to Volker from EFTA, please.
Yeah, thank you very much, Steve. So, dear colleagues, my name is Volker Teube. I'm the director of the EFTA Statistical Office, or ESO, as we shortly call it, in Luxembourg, where we are actually sited in the same premises as Eurostat. So I have the pleasure today to address a short welcome note to you on behalf of EFTA. As some of you might know, EFTA stands for European Free Trade Association. EFTA is an international organization that serves its 4 member states, which are Iceland, Liechtenstein, Norway, and Switzerland. The EFTA Secretariat has actually 3 duty stations, which is Geneva, where is the seat of the Secretary General and which negotiates the free trade agreements, Brussels, which takes care of the EEA agreement, the European Economic Area Agreement. And then we have, last but not least, Luxembourg, where we have the Statistical Office, which, beside other things, follows up also EU statistical legislation and prepares it for the integration into the European Economic Area Agreement. So the EFTA Statistical Office works together with its main partners, Eurostat and the UNECE, United Nations Economic Commission for Europe, also in the field of statistical technical cooperation. One of the products that ESO jointly with the UNECE sets up in this context are, amongst other things, webinars that address topics of relevance in official statistics, such as the present webinar on innovative methods for defining census areas. This is also conjointly organized with the Global Forum for Geography and Statistics, GFGS. Thanks also to those colleagues. In this way, we try to continue stimulating exchanges between producers that are active in official statistics on one side, despite the current corona crisis, for the sake of advancing together in order to provide also in the future high quality statistics to our users. So with this, I close here and I wish you all a fruitful seminar and overall stay healthy. Thank you.
Great. So thanks to Vilni and Volker for those words of welcome. And really now we come to the main part of the webinar, the 2 presentations. So again, for those people who've recently joined, please, the basic rules, please keep your microphone muted, your camera off unless you're a presenter. And please ask any questions that you might have for the presenters in the chat box. We will take the questions after the 2 presentations. So the first presentation is from Ana Santos of INE, the National Statistical Office of Portugal. So Ana, I invite you to show your presentation and to take the floor.
Thank you, Stephen. It's okay, are you think?
Perfect, yes.
Okay. So, hello everyone, and good afternoon or good morning for all. My name is Ana Santos. I'm a geographer, and since 1985, I've been working at Statistics Portugal in the Mapping, Census and GIS unit. And with this my presentation today, I wanted to tell you a bit about the Census Map and the way that Statistics Portugal has been producing this material for the last 3 census and as well for the next census 2021. I will start by showing a few maps that were used by Statistics Portugal. Then I will say some words about the methodology that we have used to convert the boundaries represented in these maps on the digital format and the way that we have edited the data in the office in statistical Portugal. And finally, I will present the methodology that we are applying right now to create the new geography for the enumeration areas for the next census. But first of all, I would like to thank Stephen Vale and Vilni Block for accepting this presentation. It is really my pleasure sharing this subject with all of you. Okay. My first slide shows that Portugal is subdivided into 18 districts 300 municipalities, 308 municipalities, and around 3,000 parish, the lowest administrative area. We also have 2 autonomous regions, the Madeira and Azores Islands. And concerning the NUTS division, the country is divided into 7 regions and 25 NUTS 3 or sub-regions. Now you can see on the screen the maps from the census 1981 and 1991. The first one, we only have had maps for the big cities, for the urban areas. But for the 1991 census, we have paper maps for all over the country. Those maps, for the census 91 maps, were produced in statistical Portugal, in statistical office, with a specific team to do that. But in 1995, Statistics Portugal started a plan to convert all these paper maps into digital material and started an editing process of the enumeration boundaries. This was achieved with the cooperation of the National Military Cartographic Institute and the National Mapping Cadastral Agency and the municipalities. Those entities were very, very important in this plan. For the census 91, the digital boundaries of the enumeration areas and blocks were printed and used by each enumerator. So at this time, we have all the boundaries, all the statistical boundaries in a digital format, and we have printed paper maps to each enumerator. You can see some examples on the screen. Here we can see the workflow for the digitalization of the boundaries from the census 1991. The editing process was implemented in ArcView software. First of all, as we have editing the elements, the center lines elements. And after that, we have create the polygons for each parish and each municipality. On the other hand, for census 2011, a different process was defined because we start at that time. Statistics Portugal already had an ArcSD Oracle geodatabase. And the editing process was centralized through a web application that allows us to define the new geometry for the census 2011. We start this task around 2007 to the census 2011. Okay. In this slide, we can see that over the time, we have been increasing the number of enumeration areas and the census block that we have defined to each census. You can see the definition of the definition of these enumeration areas. That is an area within a single parish that have approximately 300 dwellings. Now this number is changing for the double. In some cases, for the next census, we have larger enumeration areas in the next census because we have expect to have replies or response from internet. As you can see also, the statistical subsection is the smallest statistical area, and it corresponds to a block in the urban area, and the locality or a part of locality in the rest of the country, especially in the rural areas. We have also areas that we named residual areas, that are areas that don't belong to any locality. So it's this kind of a hierarchy that we have. And locality is a built-up area that is on it wants the designation and should have 10 or more dwellings units. As you can see in the screen also, only in the 2011 we have buildings, or the buildings were georeferenced. For the first time, it was possible to Statistical Portugal to georeference all the buildings of each census. This work was done by the enumerators during the work field. First, they used the map to identify the number of each building, as you can see. And after that, they digitized the point through a web application developed in-house, from inside for a colleague from Statistics Portugal. I need to say that this was a very good process that allowed us to give a pair of coordinates for all census building for the first time. You can see an image from the web application that it was a very simple application that were used by the enumerators. About the definition of enumeration area and the methodology used, we can see that only in on the census, or for the census 2011, we start using an algorithm to perform the aggregation of contiguous polygons in order to create the enumeration area. For the first census, the process was made in a very primary mode, or by hand, and only for the census 2011 and for the next, of course, we have used an algorithm. In particular, for the next census, this process is using a plugin for quantum GIS. We are now already using this plugin to perform the definition of the enumeration areas. So here we can see, and I would like to highlight in this slide that Statistics Portugal is obliged to disseminate census data at a locality or settlement level. And the settlement level or locality is in the map define the boundary of black boundary, and the only way that Statistics Portugal has to do that, has to publish data for this kind of entity, is through the enumeration areas, or more exactly through the census blocks, because in fact each of these small polygons that are defined in the other color belongs to a unique settlement. And as you can see, the definition of these limits is very detailed. and the limits were defined by the municipalities for all of the census. We have the cooperation from the municipalities to establish these kind of boundaries. I think in some cases, these boundaries were not clear enough to understand for the enumerator, who needs to identify each limit in the field. So, as you can see, in a more detailed way, in this slide, we have a more detailed drawing in this slide that allow us to see that the boundaries wings between the houses and make it difficult to the interviewer to interpret and to know where exactly the limit is, because in some cases it's around the house, is not corresponding a street or a line of water, and this is very difficult and very complex to the enumerators when they try to identify this limit in the field. So, due to this, or because of that, we decide to simplify the geometry for the geospatial boundaries for the next census. And I would like to tell you now about what we are doing in order to create the new geometry or the new geography for the census 2021. We ran this project in-house in the GIS unit since 2019. As you can see from the workflow, we started the editing process from the boundaries of last census, 2011, where we add the new administrative boundaries, because every year we receive from the national mapping the new borders, the new administrative boundaries, and we need to implement the new boundaries in our national database, statistical database. So we have about 16 persons are currently involved in this process, and as you can see, we start with editing the baselines, and after that we have phases corresponding to the addition, validation, and after that we create the polygons and make the aggregation process to create each enumeration area. We are doing that using the number of dwellings for the last census, 2011, and new data from the municipalities related to the new buildings and the permits construction. So we have, in fact, more or less update data for the new buildings and new dwellings that allow us to define exactly the enumeration areas and the boundaries with that number of dwellings that were defined early. So for the next census, there will be 2 different geospatial data sets and not hierarchical, as been before, the enumeration areas and the localities. And these decisions, the decision that we have taken, allow us to define a more understandable and simplified geometry for collecting data processed by workflow, by enumerators.
5 minutes.
Okay, I'm finished. Okay, so here we have some examples of the new geodatabase. We think that this kind of geometry might be easily understood by the interviewer in the field and avoid coverage errors. At the end, you will have two different data sets that I spoke about. The enumeration areas with the census blocks, and also the localities or village or settlements. With this slide, I would like to highlight that on the left of the screen, the limits were printed in the brown, were clear from the geodatabase from 2021, and in the blue we have the limits for all the subsections or census block and the enumeration areas. It's more clear and understood geometry for census purpose. My last slide is for data comparability, because between Census 91 and 2001, we have constructed a common base that allows us to compare data, because at this time we don't have buildings georeference. So the solution that we get, it was define a common base between the two census, the two geometries, and we are published data for each common base area. But for the census 2011 and the next census, we make this kind of comparability using the georeference buildings, because we can overlay the buildings with any kind of geometry, and we can count the population or other variable for each polygon that we have. So it is that way that we will perform the comparability and historic the data. Okay, my last slide is for tell you that we need to finish the data set that we are constructed now for the census. We will do it by the end of the year. And after that, we need to publish the data as an Inspire service, improving access to open data. We need to support also the dissemination of Census 2021 data. And first of all, we'd like we start a process in the beginning of the next year to collaborate with the municipalities for the delineation of the localities. This data set will be used to publish the data, and is not necessary to have for workfield purpose. So it's a second step on this project, this geography census project. So thank you for your attention. This is my last slide. I will explain after if you need some explanations extra. Thank you.
So thank you very much, Anna, for that clear presentation. That shows also something we've been promoting in UNECE, the importance of georeferencing all of the basic statistical units, whether they're buildings, people, workplaces, etc. And Anna clearly showed yet another advantage of doing that. So we already have questions coming in on the chat. I would encourage you to post any more there, and we'll ask them to the presenters after the second presentation. So now I'd like to introduce our second presenter. So here's Matthias Coupe from UNFPA, which is the United Nations Population Fund, and he's presenting on behalf of the Grid 3 project. So, Matthias, we see your slides and they're just going full screen now. Perfect. The floor is yours.
Thank you very much, Stephen. So, yes, my name is Matthias Kripe. I am from UNFPA, member of the GRIP 3 project. GRIP 3 is Georeference, Infrastructure and Demographic Data for Development. So it is a joint project of UNFPA, CISEN, WorldPop, FlowMinder, and it is founded by the Bill and Melinda Gates Foundation and also the UK 8. So my presentation is on new tools in creating and monitoring enumeration areas for the 2020 round census. So clearly it is tools or approaches that has been developed within the project. So it is not only my own work, but it is the work of all the GRIP 3 partners. So the agenda of the presentation, I will give an overview, a quick overview of all the projects, and then define and the challenge, give the definition and challenge in creating EAs, and then discuss some approach and tools that has been used in the context of Burkina Faso, in the context of Congo Democratic Republic, and in the context of the Ghana. So first of all, the overview of the project. So as I have already said, it is a partnership, a global partnership with founding partners, so Bill and Melinda Gates and the UK 8, and the implementing partners who are WorldPop from Southampton in UK and FlowMinder in UK too, UNFPA, and a managing partner which is CISEN in the University of Columbia. So now GRIP 3 is working in a certain number of countries who are listed in the left part of this slide. Mostly African countries. There are some potential countries with whom we are discussing right now to see if they can integrate the project. What the project does, the project objective is to produce high resolution population estimates, also high quality georeference censuses, working on settlements, localization, harmonization of boundaries, infrastructure mapping and analysis, and also capacity strengthening in all the countries in which we are intervening. So that is a clearly very ambitious and I hope a very useful project for African countries. So now, regarding the challenge facing when creating EAs, it is important, first of all, to mention that EAs is the result of the subdivision of a country into geographical units during the census mapping process. At the right, you have, I gave some example of EAs, both paper-based EAs and digital EAs, as my colleague Anna shown the process of shifting from paper-based EAs to digital EAs in the case of Portugal. So here, these are two examples in the African context, just to give you an example. And the general requirement of EAs, I think Anna also talked about it. So the first requirement is that an EA should not cross an administrative boundaries or some ground obstacles. It should be easily identifiable on the field. So it should be of reasonable size, not too big, not too small, so that an enumerator can cover it within the enumeration duration. So, and also all EAs should form a finite partition of the countries, of a country, so no overlap and no gap. And it should also, EAs are also meant to fill the needs of the governments and the government's departments and other data users. So this is also an important requirement of an enumeration area. So additionally, features and opportunity for around 2020 census EAs is that one should use the digital EAs. There is an opportunity to, there is the opportunity to superpose, of the superposition of different geospatial layers. There is a possibility to use GIS tool to improve the coverage and monitoring of and the quality control of EAs. So that's the main opportunities for the new round census. So now I'm going to present the approaches and tools in three different contexts, as I've already mentioned. And for each of these contexts, so Burkina Faso, DRC, and then Ghana. And for each context, generally, the approach or the tool that has been developed is to answer or to answer to a specific need or a specific to address a specific issue. So, for instance, in the case of Burkina Faso, the objective was to combine a paper-based map and a geospatial data to produce new digital enumeration areas. This, of course, in the context in which the Burkina Faso conducted its fifth census during from December 2019 to January 2020. So they use paper-based map cartography, and this cartography was conducted 1 year ago. But they use copy data collection with household GPS coordinates. And we are in a country who is facing a security challenge in some parts of the country. At the right side, I just gave an example of a paper-based cartography of a municipality. And what is interesting, so you just see we have something that is the map of the municipality, but inside the enumeration areas are just sketches, so just lines that are drawn to localize each enumeration area. Of course, after this is the overall map, and generally after this, for each enumeration area or some block of enumeration area, there are some sketches that are drawn and help on the field. So here clearly the challenge was the following. After the census, the Burkina Faso National Institute of Statistics wanted to take the opportunity of the collaboration with Grade 3 to modernize the cartography for coming surveys, and also in the preparation surveys for the master sampling frame, and etc. So we have the paper-based maps and the household GPS of the GPS coordinate of household from the census. And the challenge was to create a geodatabase of digitalized EAs for that will follow the requirement of the country. And one of the requirements was that it should include the boundaries of the different localities or villages of the country. And that's de facto boundaries, because these boundaries doesn't exist themselves, but are generally on the field. Households are recorded according to their village. So they give the name of their village, and then they can be organized by village. And at the lower right side, you can see you can see a map with the GPS coordinates of different households belonging to different EAs as they were collected on the field. So based on that, the objective was to shift from the sketches to digital map. And the case of this of the municipality you have on in the screen. So at the left is a paper-based map, and on the right side it is the outcome of the digital map. And to achieve these results, first of all, one thing that was very important was to work with Burkina Faso cartographer who have a long-standing field experience in Burkina Faso. So they were able to combine, to read from the paper-based map, and then with geospatial data, different kind of geospatial data. So locality points, waterways, roads, paths, and also household GPS coordinates, and the building footprint from Marsa, who is a partner of Grade 3 project, who provide us with building footprint of most of the African countries. So with all these data, we were able to digitize or to help the Burkina Faso National Statistical Institute digitizing the EAs. And here you have on this slide the EAs that has been digitized in the rural context, and in the left side, and on the right side in an urban context. So that is what has been so far done in Burkina Faso. The work is still ongoing on the field by the local team under the supervision of the Grade 3 partners. So now,
5 minutes, Matthias.
Okay, thank you. I will try to speed. So regarding the case of DRC, the objective was the following. In DRC, generally, the last census was 36 years ago, and the problem, so they don't have the previous EAs, and it is very, very out of date. And here also, given the COVID situation and also the conflict, so we are in a context where finally going on the field is not very easy. So we need preparation. And in the case of DRC, the objective was to develop an automatic tool which use as inputs data, the georeference, different georeference layers, like the roads data, the waterway data, the administrative boundaries. Combine this data with the high resolution gridded population, which is estimated within the grid 3, and then put all this data in together and then split it into very small pieces, with each small pieces of area having a population count, and then recombine all the data, all the small pieces to produce areas that are what we call pre-EA. So EAs produced to go, which can be validated on the ground if possible, and it is the right site, at the right side, so you can see some example of pre-EAs. So as I have already said, for this, we need some input data, which are mostly geospatial data and administrative boundaries, and then we apply the tool. Here is just to give you a picture of the tool interface. It is still in development, but we have already tested in DRC and in other countries. And of course, this is just, this slide give you the ground validation. So after applying the tool, producing the pre-EAs on the field, we went on the laboratory, we went on the field and validated the output in different settings. So in urban setting, in urban area, and in rural area. So now for the Ghana, I will be very short, because for the Ghana, it is another tool that was developed called the hard to count tool. Here, the objective was that in the process of the preparation of the census, generally those who have already done a census or a survey knows that sometimes it is difficult to reach all the households in a given area, especially in the enumeration areas. And the objective here was to anticipate and produce an indicator for each enumeration area, which gives the difficulty to access that area, or to perform, to work in this area. And these difficulties depends on the shape, on the size, on the accessibility, and on the estimated building and distribution in the area. So that was applied in Ghana, using all these indicators, which can be classified in 3 types of indicators: geometric indicators, accessibility indicator, and building density indicators. So here I will go fast and then just mention the fact that when we build this indicator, we were able to identify EAs that are difficult to reach. And I will say that it is a work which is also ongoing, but which is very promising in monitoring EAs on the ground. And so just to conclude here, I will say that the abundance of geospatial data and technology is an opportunity for us, especially in the African context. So to shift, it helps shifting from paper-based cartography to numeric cartography. It helps to develop automatic tools to create in efficient and effective ways enumeration areas. So it also helps in developing tools to monitor enumeration area and cartographer work in the EAs. And ultimately, it helps improving census quality. Thank you very much.
Great, thanks Matthias for that presentation, and it's good to see how things are working in different countries there. So thank you for those examples. So now we come to the question and answer part, and here hopefully you see my screen. We had some questions coming in for Anna, and please keep questions coming in on the chat for both Anna and Matthias. But Anna, I won't read them all out. You can see them on the screen, so I'll let you work your way through those, Anna.
Okay, I will start with buildings register. In fact, Portugal doesn't have an official building register, building and dwelling register, and for that was decided, or because of that was decided to create its own building file from the Census 2011 data. That allow us to implement a new sampling infrastructure, because in the past, Statistics Portugal has a master sample, and right now, in this moment, we have a sampling infrastructure that use the list of the buildings, and dwellings that are permanent in updating process. So respond to the question. This file is belongs to Statistical Portugal, but we are sharing this data with some entities, especially within administration, in public administration, in order to promote our identifiers, because our problem, I think is not only our problem, but one of the problems that we have is we don't have common identifiers. So we will promote the use of these identifiers from census with the other entities from public administration.
Okay, great. Thanks, Anna. And while you were talking, we also have some questions that have come in for Matthias. So I've just got to juggle my screens and share those. Make sure I share the right ones. Okay, let me just escape from this. And try again.
I can comment the question about the address. In fact, the address in our case is a variable that is linked to the building coordinates. So we have for all census building, we have an address that is in some cases is a standard address, but in other cases, especially in rural areas where we don't have street names and number of houses, we have especially the locality and the postal code. But where is an address, we try to collect them, and that is a variable of our register building.
Great, Thanks, Anna. Matthias, I've put your questions on the screen, so hopefully you see those.
Yes.
Over to you.
Yes, okay. Thank you very much for this question. And I will start with the question of Valentina, for which Anna gave some answer. I will say that, yes, for Burkina Faso, the GPS coordinates were collected for all dwellings during the census project. So it is just a GPS signal who are collected the GPS coordinates of all the household. It is not easy in the context of a country like Burkina Faso, because first of all, there were security challenge in some part of the country, so they didn't went there. So for that part of the country, we use population modeling, and also sometimes there were problem of the energy of battery, something like that. So at the end, for all the country, we had a GPS coordinate of only which were usable of only 2/3 of the households of the overall countries. And that's why for the EA digitalization, we need to complement, to add the building footprint down to the satellite imagery. So all the building footprints of the buildings of the country were collected. So we use it as an additional data to localize where dwellings are in the country. So that's what I can say. And regarding the first question about the value added of the pre-EA's version, EA demarcation. So I would say the pre-EA, it is in the laboratory, because when doing the cartography, the census cartography, before going on the field to delineate EA, to delineate supervision or control zones, you need to have to already organize the work. And generally, EAs are the EAs of the previous censuses are used and then updated on the field. But that suppose that these EAs from the previous census are reliable to certain extent. In the case of some African countries, this is not the case, especially when the last census is too old, or when it is also the EAs are not accessible, or when the cartography work was poorly done. So in that case, the pre-EAs, having a pre-EAs database is very important, because then all the country is subdivided, organized, and then when cartographer go on the field, they can update and modify, but at least they go on the field with knowing with data, preliminary data. And regarding the question of team, yeah, in general, it is very difficult, especially in Africa, to know the real role of the national mapping or geospatial agency. It is not easy, because sometimes there is competition between different institutions. It is not only the case in Africa. I think in a lot of countries, we also sometimes face the competition between institutions. And so, of course, there is a partnership with the national mapping, but they are not very well integrated, to my opinion. I saw that in the case of Burkina Faso, they just provide some data, given that they are public institutions, they provide some geospatial data the National Statistical Office, but they didn't take part fully in the mapping process, in the census mapping process. And I also see the same situation in Ghana, where there was a geospatial agency which was very skilled in GIS techniques, but the National Statistical Institute was struggling with geospatial problems, but the two institutions were not working in a very cooperative way. So it is not easy. Over.
Great. So thank you very much to both of you for answering those questions. Actually, just as we were finishing we have one last question come in on the chat. I know we're just about on the time limit, but Anna, this one is to you. I'll just read it out. How do you transfer data from census blocks to the non-hierarchical settlements, assuming the boundaries are not coincident?
Oh, okay. We expect to do that using the overlay with the buildings, because actually we are doing that for the geometry from the last census, 2001 and 1901. We overlay the data, the building data with those polygons, and we count the population or the other variable. So the historic, in summarizing, the historic, we achieve the historic using the buildings and not in a polygon way, as we made for the first census with a common base. I don't know if I can comment the last question from Team Trainer. In Portugal, we have a very good cooperation with national mapping, but we are responsible for the statistical units inspired data. We have the responsibility to harmonize the data and to publish the data as a service. We are doing that under the collaboration of national mapping, but in fact we are the responsible for that data. We receive the base maps, and all the editing process that we are doing are based on the base maps, orthophoto maps from the mapping agency. Thank you, Stephen.
Great. So thanks again for answering that bonus question. I see that there are some follow-up comments also appearing in the chat, but we are pretty well at the end of our time. In fact, we're a couple of minutes over. What I'd like to do is just very briefly summarize that we had some very useful and interesting ideas here, which hopefully those of you in the audience will be able to get some inspiration from for your work in defining census areas and other geographies for statistics. As I mentioned at the start, the recording and the presentations from this webinar will be made available on the GFGS Wiki, and that will be on the page where you went to do your registration. So you should already have the link for that. This is the first in a series of webinars or coffee talks, as Vilni called them. And we have already an idea for various other topics related to statistics and geography, probably enough for another 4 or 5 at least, but we also welcome any volunteers. So if anybody in the audience has anything that you are working on that you think may be interesting, related to geography and statistics, then please let me know and we'll see if we can include you in the schedule somewhere. So then the final thing to do for me is to thank our two presenters, Anna and Matthias, for sharing their information with us, and to thank the partner organizations, GFGS and EFTA, and finally to thank all of the participants. So thank you for making this an interesting webinar, and it sets a high standard for the rest of our planned series. So I look forward to seeing you next time, probably second half of January, but we'll send something round by email to all the participants, so you'll have the full information on that. So, unless anybody wants to add any final words, I think we can close the webinar at this. So thank you. Have a very good rest of the day wherever you are. Thank you.
Thank you. Goodbye.
Thank you.
Thank you. Bye-bye.